Vitalik Buterin published something this week. He runs his LLM agents in a sandbox, specifically to limit what a process can reach. His exact words on the topic: malicious activity can happen too quickly to be detected. So we built that boundaries for Arbitrum agents. Let me show it to you. In the last video we saw the Open Wallet standard, and it gives you the right primitive to manage your secrets. Instead of holding your agent a private key, what it has is a scope token with a maximum amount or an expiration date, and the vault where these keys are stored is encrypted and any policy runs before decryption. But OWS has a gap that they documented themselves. The signing core still lives in the same process as the agent. The subprocess enclave is still in their roadmap but is not yet developed. I added this process isolation to reduce the window for key extraction. Here you have the architecture. You have two containers, one Unix socket, that's the only thing, and on the left side what you have is the agent container that will hold like the scope tokens, of course, but no private key, no raw credentials anywhere in this environment on the agent 1. So on the right side what we have is the KMS container, the key management system container. This holds everything else, like the OWS vault, where it receives requests from this specific tokens on the socket, and then it returns signatures. That's all it can do. So Vitalik, what it posted is that it uses bubble wrap, so it's a similar idea, but in a different level. It depends what you're building. He's unboxing the process on one machine. What we are doing instead is isolating the signer in one side from the agent. So this would be the signer and not attached within the same machine, or in the same machine but different processes. That's what I think that it's the right foundation for multi-agent system. And here's the part that I like the most. This is not just for wallet keys and for tokens. It's specifically for any API key, for Anthropic API keys, Alchemy, RPC endpoints, your database, so any credential that you might need for your agent, you shouldn't have to hold it directly. You can manage in the same way that we are managing a scope tokens and asking this signer to do several actions. So you have one container that manages the secrets of all the architecture, and then you can have multiple instances of agents that can ask for signatures. We have started with the wallet. You can use it for the rest, but if you want to start, it's as easy as running a Docker Compose app, and this will start two Docker containers, one for the KMS and another one with a P agent. So the KMS has an OWS wallet, so you can see here that you have your wallet creation that is happening right now, and the first thing that it does, the agent, is to request a first token to be able to operate. That's something that we did for the demo, of course, because we don't want to start the request and everything again. Basically what we can do now is from the Docker container of the key management system, what we can see is the actual request that we have right now. So we can see that our P agent has created a request for an initial token to be able to sign whatever he wants to. So what we can do is first run the approval, and then we will go for the specific request, and we have approved. So then the agent that is like loading said, okay, now I have my own scope token, I can start. So what we can do now is open an interactive chat with our agent in the container, and say, maybe we can say, here we have an example. So we can say, hey, sign this message on the EVM that says hello world. So it will load the skills on how to properly sign with OWS scope tokens, and in a matter of seconds, there we go. We have it. We have this message. This is the signature and the message that we have sent, and obviously this is using the approved token that the KMS system running in complete separate processes. An attacker or prompt injection could break an agent, but not this with KMS. That's the whole point. We have designed a zero trust wallet architecture for Arbitrum agents, and not a .env, not a raw key, there are not compromise found here. Vitalik used bubble wrap, we used Docker here. That's the same idea. So the secrets don't live next to your LLM process. So P1 is open source, code is in the description, follow me if you like the content.